Hey everyone, welcome to Aionlinecourse. In today's video, we're working on a fun NLP project. Topic modeling using k-means clustering to group customer reviews. If you have lots of customer reviews, we'll show you how to clean, analyze, and group them using tools like NLTK, Scikit-learn, LDA, and k-means. We'll also use word clouds and heat maps to easily see important ideas. Now, I will present a detailed, step-by-step overview of the entire development process. Step 1. Data collection, get customer reviews from a public dataset. Step 2. Data pre-processing, clean the reviews by removing noise and standardizing the text. Step 3. Exploratory data analysis, look at rating trends and common words in the reviews. Step 4. Sentiment analysis, label reviews as positive, neutral, or negative. Step 5. Topic modeling, find hidden topics in the reviews using LDA. Step 6. Clustering group similar reviews using k-means. Step 7. Visualization, show results with word clouds, heat maps, and cluster plots. Before we start with the code, head over to Google and search for topic modeling using k-means Aionlinecourse.com. On Aionlinecourse, you'll find the complete guide with detailed explanations and well-structured content. Now I'll show you the full code step by step in Google Colab and explain each part clearly. First, mount Google Drive in the Colab environment at Content Drive, allowing you to access and save files between Colab and Drive. Install required libraries. We're installing all the essential libraries for text cleaning, data analysis, machine learning, and visualization used in this project. We use this code to hide warning messages and keep the output clean and easy to read. Now we download NLTK tools for text processing, such as Punkt for tokenization, WordNet, and 1.4 for lemmatization, stop words for filtering common words, and Vader lexicon for sentiment analysis. We import libraries for text processing, data handling, machine learning, visualization, topic modeling, clustering, and model evaluation to build and analyze our customer reviews project effectively. We load the dataset from Google Drive and display the first few rows to check the data. The output shows sample hotel reviews and their ratings from 1 to 5. We get the percentage of each rating in the dataset. Most reviews are positive, with ratings 5 and 4 making up over 70% of the data. Rating distribution. We plot a colored bar chart showing the number of reviews for each rating. The histogram shows more positive reviews, with ratings 4 and 5 having the highest counts, indicating mostly positive feedback. We add a length column that counts characters in each review and display the first rows. The output shows the first 5 rows with the new length column displaying the number of characters in each review. We plot a KD chart to compare how review lengths vary across different ratings with colored curves for each rating. The plot shows most reviews are short, low-rated reviews are shorter, while higher-rated ones are a bit longer. Clean and pre-process reviews. We create a clean text function to pre-process reviews by removing numbers, punctuation, repeated letters, and stop words, converting text to lowercase, and lemmatizing words. Then we apply it to clean all reviews in the dataset. We count how often each word appears in all reviews and show the top 20 most common ones. The output lists the 20 most frequent words in reviews, showing common topics like hotel, room, great, and staff. Top 20 most common words. We create a horizontal bar chart to show the top 20 most common words in reviews, using different colors for each word. The chart shows the top 20 frequent words in reviews, mainly about hotels, rooms, staff, and stay, highlighting key travel topics. Word cloud of top words. We create a word cloud shaped like a hotel icon using the top words, with a light yellow background and red outline, then display it. The word cloud highlights the most common words in hotel reviews, with hotel and room being the largest, showing key topics and positive guest experiences. Sentiment classification using Vader. We use Vader sentiment analysis to label each hotel review as positive, negative, or neutral based on its compound score. Reviews with scores greater than 0.1 are marked positive, less than -0.1 as negative, and the rest is neutral. This sentiment is stored in a new column, and we print the count for each category. The output shows that most reviews are positive 19,305, while negative 1,045 and neutral 141 reviews are much fewer, indicating that customers generally had a good experience. Map ratings to true sentiment. We map numerical ratings to sentiment labels and create a new column, true sentiment, where ratings 1, 2 are negative, 3 is neutral, and 4, 5 are positive. The output shows the first 5 reviews with their predicted sentiment and true sentiment. It highlights how sentiment analysis compares with actual ratings. Sentiment analysis confusion matrix. We calculate a confusion matrix to compare true versus predicted sentiments, then visualizes it using a heat map to assess sentiment classification accuracy. The confusion matrix shows the model predicts positive sentiment most often. It correctly identifies many positive reviews, 15,031, but misclassifies many negative, 2,188, and neutral, 2,086 ones as positive. This suggests the model is biased toward predicting positivity. Sentiment classification performance metrics. We create a classification report showing precision, recall, F1 score, and support for each sentiment class, comparing true labels with model predictions to evaluate performance. The model performs well in detecting positive reviews, with high precision 0.78 and perfect recall 1.00. However, it struggles to identify negative and neutral sentiments, showing low recall and F1 scores, particularly poor for neutral at 0.02. This indicates an imbalanced performance despite an overall accuracy of 78%. We categorize ratings into positive, neutral, and negative groups, then assign each rating a sentiment label accordingly to create a new sentiment column in the dataset. Now we convert review texts into numerical features using TF-IDF with unigrams to trigrams, then split the data into training and testing sets for model development. Random forest model training and evaluation. We train a random forest model on the training data, make predictions on the test set, and then evaluate its accuracy and detailed performance using a classification report. The model has 80% accuracy, performs well on positive reviews with perfect recall, but poorly detects neutral and negative sentiments, especially neutral with almost zero recall. This shows imbalanced class performance. Build confusion matrix. We generate a confusion matrix to visualize how well the model's predictions match the true sentiment labels, then display it as a heat map for easy interpretation of classification errors. The confusion matrix shows the model is biased toward positive sentiment, correctly predicting most positive reviews. However, it struggles with neutral and negative sentiments, often misclassifying them as positive, indicating poor class balance and limited distinction between the classes. Bar chart of model performance metrics. We convert the classification report into a data frame and visualize precision, recall, and F1 score for each class using a bar chart to better understand the model's performance across sentiment categories. The bar chart shows that the model performs best on positive reviews with high precision, recall, and F1 score. It handles negative reviews moderately well, but struggles significantly with neutral reviews, showing very low recall and F1 score. Overall accuracy is around 80%, but macro averages highlight imbalanced performance across classes. Build the multinomial naive Bayes model. We train a multinomial naive Bayes model on the training data, make predictions on the test set, and evaluate its performance using accuracy and a detailed classification report. The model shows strong performance on positive reviews and fair results on negative ones, but fails to detect neutral reviews, leading to an overall accuracy of 82% with imbalanced class performance. Confusion matrix heat map for sentiment classification. The confusion matrix compares the true sentiment labels with the predicted ones, showing how well the model classified each category. The heat map visually highlights the correct and incorrect predictions across negative, neutral, and positive sentiments, making it easy to evaluate model performance at a glance. The heat map reveals strong accuracy for positive reviews, but poor detection of neutral ones, which are often misclassified. Negative reviews are mostly correct, but sometimes confused with positive. The model shows a bias toward positive predictions, likely due to dataset imbalance. Classification metrics comparison across sentiment classes. The classification report summarizes the model's precision, recall, and F1 score for each sentiment class. Visualizing these metrics side by side helps quickly compare how well the model performs across different categories, highlighting strengths and weaknesses. This bar chart titled Classification Report Naive Bayes shows precision, recall, and F1 score for negative, neutral, and positive sentiments. The model performs well on positive reviews, moderately on negative, but struggles with neutral ones. Overall accuracy is about 80%, reflecting class imbalance and difficulty with neutral predictions. Building and evaluating XGBoost model. We train an XGBoost classifier on the training data and use it to predict the test set labels. We then calculate and print the model's accuracy along with a detailed classification report showing precision, recall, and F1 score for each class, which helps us evaluate the model's performance on the test data. The XGBoost model achieved 84% accuracy, performing very well on positive reviews, fairly on negative ones, but poorly on neutral reviews, which are often misclassified. Classification report visualization for XGBoost model. This code generates a classification report for the XGBoost model's predictions, extracts precision, recall, and F1 score for each class, and plots these metrics as a grouped bar chart with distinct colors. The chart is titled and labeled clearly, allowing easy visual comparison of the model's performance across different classes. The classification report XGBoost chart shows strong performance on positive and negative reviews, but poor results for neutral ones. With about 90% accuracy, XGBoost outperforms other models, but still struggles to correctly identify neutral reviews due to data imbalance. Build and evaluate logistic regression model. We build and train a logistic regression model with a maximum of 1,000 iterations. After fitting it on the training data, we predict the test set labels, calculate the accuracy, and print a detailed classification report to evaluate the model's performance across classes. The logistic regression model achieved 85% accuracy, performing well on positive and negative reviews, but struggling with neutral ones, which have low recall and F1 score. Overall, it handles class imbalance fairly. Logistic regression confusion matrix heat map. This code creates and displays a heat map of the logistic regression confusion matrix to visualize prediction accuracy across sentiment classes. This heat map shows the model's confusion matrix for sentiment analysis. It performs very well on positive reviews, moderately on negative, but struggles to identify neutral reviews, often misclassifying them as positive. There are 4,346 correct predictions and 777 errors, indicating a bias toward positive predictions, likely caused by dataset imbalance. Classification report visualization. This code generates a classification report for the logistic regression model's predictions, extracts precision, recall, and F1 score for each class, and plots these metrics as a grouped bar chart with different colors. The chart is titled and labeled to clearly show the model's performance across sentiment classes. The bar chart shows the logistic regression model's performance on sentiment classes. Strong results for positive and negative reviews, but poor recall for neutral ones. Overall accuracy is about 85%, with weighted averages reflecting the class imbalance, favoring positive reviews. The model struggles most with neutral sentiments, similar to other models. Build and evaluate linear SVC model. We train a linear SVC model for sentiment classification and evaluate its performance using accuracy and a classification report to understand how well it predicts negative, neutral, and positive sentiments. Linear SVC achieved 84.8% accuracy, performing well on positive and negative reviews, but struggling with neutral ones. High precision and recall for positive reviews boost overall performance, though class imbalance affects neutral sentiment detection. Confusion matrix, linear SVC sentiment classification. We visualize the linear SVC model's confusion matrix as a heat map to compare true and predicted sentiments negative, neutral, and positive. The heat map shows the model excels at positive reviews, does okay on negatives, but struggles with neutrals, often misclassifying them as positive. There are 4,344 correct and 779 incorrect predictions, reflecting class imbalance bias. Classification report, linear SVC model. Now we plot precision, recall, and F1 score from the linear SVC model's classification report as a clear bar chart to visually compare its performance across sentiment classes. The bar chart shows linear SVC's 85% accuracy on sentiment analysis. It performs well on negative and positive classes, but struggles with neutral, especially in recall. This is likely due to class imbalance and overlapping features, similar to other models. Model accuracy comparison. We compare the accuracy of 5 models by listing their names and scores, then sorting them to show which performs best on the task. The comparison shows that logistic regression performs best with an accuracy of about 84.8%, closely followed by SVC at 84.8%. XGBoost ranks third with 83.9%, while naive Bayes multinomial and random forest trail behind with 82.1% and 80.6%, respectively. Overall, logistic regression and SVC lead in accuracy for this classification task. We plot a bar chart comparing accuracy scores of 5 models: random forest, naive Bayes, XGBoost, logistic regression, and SVC. Each bar displays the accuracy percentage on top, with clear labels and a title to easily see which model performs best. The bar chart titled Model Accuracy Comparison shows accuracy scores of 5 sentiment analysis models. Logistic regression and SVC lead with 85%, followed by XGBoost 84%, naive Bayes 82%, and random forest 80%. Topic modeling. We prepare text data for topic modeling by pre-processing customer reviews. It lowers the text case, tokenizes each review into words, removes common English stop words, filters out short tokens, less than 3 characters, and applies lemmatization to reduce words to their base form. The cleaned tokens for each review are stored in a list for further analysis. We build a word dictionary and corpus from pre-processed reviews, then train an LDA model to find 5 topics. The model outputs keywords for each topic, revealing main themes in customer feedback. The LDA model found 5 topics, focusing on hotel rooms, staff, food, location, and amenities, summarizing key themes in customer reviews. Clustering negative reviews using k-means and TF-IDF. Negative reviews are vectorized using TF-IDF and clustered into 3 groups with k-means. The adjusted RAND index evaluates how well these clusters match actual ratings. An adjusted RAND index of 0.0186 shows poor alignment between k-means clusters and actual negative ratings, likely due to similar language in 1- and 2-star reviews. We reduce the TF-IDF vectors of negative reviews to 2 dimensions using PCA for easier visualization. Then, we extract the top 10 keywords from each k-means cluster by analyzing the sorted cluster centroids, helping us understand the main themes in each group. The clusters reveal key themes in negative reviews. Cluster 1 relates to room and stay comfort, Cluster 2 focuses on service and staff issues, and Cluster 3 highlights problems with resort facilities like the beach, food, and pool. These terms summarize main complaint areas. We visualize the negative review clusters in 2D using different colors to distinguish each cluster clearly. The scatter plot visualizes 3 text clusters: negative red, neutral mixed green, and positive blue reviews. Clusters overlap slightly, reflecting shared topics, and align with earlier sentiment and topic analysis results. Now we generate 3 word clouds, 1 per cluster of negative reviews, using a hotel-shaped mask and different background colors to highlight the most frequent words, helping visualize key themes in each cluster. The word clouds show 3 review clusters. Cluster 1 highlights negative room issues, Cluster 2 reflects mixed service experiences, and Cluster 3 features positive resort-related words, matching earlier sentiment and clustering results. Text clustering for positive reviews. This code clusters positive reviews using TF-IDF and k-means into 3 groups, then evaluates how well the clusters match actual ratings with the adjusted RAND index. The adjusted RAND index of 0.0177 shows very low agreement between the k-means clusters and the actual positive ratings, indicating the clusters don't clearly reflect the rating distinctions. We reduce the TF-IDF vectors of positive reviews to 2D using PCA for visualization. Then, by sorting the k-means cluster centers, we identify and print the top 10 words that characterize each cluster, helping to reveal the main topics within the groups. The positive review clusters highlight key themes. Cluster 1 centers on resorts and leisure, Cluster 2 focuses on hotel stays and service, and Cluster 3 emphasizes hotel comfort and amenities. These reflect the main positive aspects valued by customers. This plots positive review clusters in 2D using PCA, coloring each cluster differently to visualize the k-means grouping clearly. We generate word clouds for each of the 3 positive review clusters, using a hotel-shaped mask and different background colors to highlight the most frequent words in each cluster for easy visual interpretation. The scatter plot shows positive reviews grouped into 3 clusters based on text features. Each cluster highlights different positive themes like resorts, service, or rooms, with some overlap reflecting shared content across groups. The word clouds highlight 3 positive review themes. Cluster 1 centers on resort amenities like beach and pool, Cluster 2 focuses on overall stay and service quality, and Cluster 3 emphasizes hotel room comfort and cleanliness. These clusters align with the scatter plot groupings, confirming distinct but related positive feedback themes. We successfully built a topic modeling pipeline using k-means clustering to group customer reviews. Through text preprocessing, sentiment analysis, TF-IDF, PCA, and clustering, we revealed hidden themes and organized similar reviews. Visualizations like word clouds and scatter plots enhanced understanding, showcasing the power of NLP and unsupervised learning in extracting insights from text. For the full code and to explore more exciting projects, visit Aionlinecourse.com. That's all for today's video. Thank you for watching. If you liked this project, don't forget to hit the like button and subscribe for more tech tutorials. Check out our next video on object detection with Yolov 8, link in the description. See you in the next one.